Okay, what I'd like to do on this series is go through a series of problems that are associated with some fundamental math skills that are associated with chemistry. So this is going to be math skills, and there's several of them. The first math skill is the idea of scientific notation. In chemistry, the numbers are often very, very big, and sometimes they're very, very small. And we need to represent numbers in a way that allow us to mathematically manipulate, add, subtract, multiply, divide these very big and very small numbers. And therefore, we need to put these numbers in a format that allow us to do that. And so we're going to take a look at scientific notation, and we're going to take a look at how to work with numbers in scientific notation. Specifically, we're going to take a look at multiplication of scientific notation numbers, and look at division in scientific notations. And this skill set will run throughout all the units that you're going to encounter in chemistry. In addition, we need to be able to convert numbers from one unit to another. For example, we'll need to convert centimeters to, say, meters, or joules of heat to kilojoules of heat. And so the ability to take these numbers and shift them to different units is again something that we will be looking at and using throughout the course, and we need to have a very good management of that. And the final idea is really a method, and it's a method whereby we run calculations. And that method of calculation is usually not familiar to a lot of students. This is your first introduction to it. And that method is referred to as dimensional analysis. And what it basically is a shorthand method to carry out a number of calculations associated with a problem. And again, I'd like to emphasize to you that you'll be using scientific notation, unit conversion, and particularly dimensional analysis throughout all units in this chemistry. One might be suggesting that these skills are like the skill set associated with running very, very fast. And you use running fast in football, in basketball, in lacrosse, and a whole bunch of sports. This basic skill of running shows up. Well, that's what these are. These are skills associated with mathematical manipulation, and you'll see it showing up in our heat unit. You'll see it in our stoichiometry unit. You'll see it during our equilibrium unit, and virtually all units that we're going to encounter, you'll be using the skill set. And so a mastery of it becomes very, very important. So let's take a look right now at scientific notation. That was a bit, there we go. So I'm going to work a series of let me get my colors correct here. Hang on. There we go. Let me see if I got it now. Much better. So what I'm going to take a look at now is scientific notation. Now there really is two parts to scientific notation. First one is putting numbers into a scientific notation format. And then the idea is to manipulate numbers in scientific notation. So first we have to be able to convert into numbers that are in scientific notation, and then we're going to have to do mathematical operations with them, such as multiply and divide. So let's take a look at the first one, converting. Example A. Okay, if you have the number 8,100, that is a difficult number to actually work with and manipulate because it is somewhat large. So what we do is we convert it to 8.10 times 10 to the third. So what we've done is we move the decimal point, which is not there but is implied, and we move it 1, 2, 3. We always move it to the just after the leading digit of the number, which in this case is 8, and we place the new decimal point. And so when we say it's times 10 to the third, what we're effectively doing is saying we've moved the decimal point from the actual number over 3. Now there's going to be some confusion sometimes, and so here's my take-home statement. This number 8,100 has been made into a much smaller number, which is 8.10. That's a much smaller number than 8,100. So we have to compensate for our change, and so we have to put a positive 3 here. And you'll see why I make a big deal out of this, but suffice it to say for right now, when you make this number smaller, then you have to compensate by adding 10 to the third to it. And so that's a conversion. Now let's take a look at a second example of converting. In this example, we're going to take the number 0.03050. We're going to convert that number. Now to do that, once again, we want to move the decimal so that the leading number is followed by a decimal. So that becomes 3.050. But notice we've taken a small number and turned it into a bigger number. 0.03 is smaller than 3.05. So in order to keep the number to the proper scale, we're going to have to put it to the -2. So if the small number becomes a bigger number, the way I think about it is you got to knock it down with 10 to the -2. So the minus value versus the plus value, that's the way to think about it. I did make a mistake. We don't want that one there. We just want 2 digits. Let's take a third number, 0.0120. We're going to convert that 1, 2, so it's 1.20 times 10. This number was small. We've made it a bigger number, so it has to become a -2. Let's take a look at one more. Example D. We have 50 million. Big number. Difficult to work with. So we're going to move it 1, 2, 3, 4, 5, 6, 7. We'll go 5.00 times 10. Notice we took a big number, made it a small number, but we're going to have to therefore compensate by raising it to a 10 to the plus 1, 2, 3, 4, 5, 6, 7. So notice we've taken numbers that are both big and small and converted them to a uniform standardized format. And notice when we do so, we always make the leading digit followed by the decimal. We always go 2 values past to the hundredths place. And notice that you can have a plus exponent or a minus exponent depending upon if you made the number smaller or if you made that number bigger. Let's now take on a new idea, and that new idea is going to be doing let's see here once again, ran into issues, there we go, is going to be math operations using scientific notation. Okay, now let's take a look at what we mean by this. If you have a number 18.5 and you're going to divide that number by 0.035, I'm fully aware that on today's calculators that's an easy series of button strokes and you're good to go. But in fact, the numbers that we'll be working with in chemistry are eventually going to be much more sophisticated, more complex, more large and more small. And so what we want to do is we want to actually convert each of these numbers to scientific notation. And then we're going to do the actual operation itself. So let's do the conversion first. So we're going to convert 18.5 based upon the last section we just did. We're going to convert it to 1.85, and again the number went from bigger to smaller, and so we had to compensate for the smaller number by taking it 10 to the positive 1. And it's a positive 1 because we moved it once this way. Now we want to then take 0.035 and we're going to convert it again to the scientific notation, which is going to be 3.5 times 10. And because this is a smaller number made bigger, we've got to knock it down a little bit. We're going to set that to a -2 because we've moved it twice. Now what we're going to do is we're going to actually do the operation. We're going to now actually do the math. Now we never in chemistry actually use the symbol division. Instead, in chemistry, when you set up a division, what it always represents is a ratio. Now we'll see that in our next area, which is unit of conversions. So in chemistry, numbers are not just numbers. Numbers are measurements that have been made. Now, that may not have made sense yet, but bear with me when I say we're going to have to never use this symbol division. We're going to set it up as a ratio. So we have the number 1.85 times 10 to the first divided by, we're going to set it up as a ratio, divided by 3.5 times 10 to the minus second. Okay, now, what does one do here? Here's the best way to think about what one does. What you do is you take the ratio and you divide it into two parts. Here is the exponent part, and here is the actual numbers. And what you do is you solve these two differently, and you solve them separately from each other. What are you trying to say here? What we're saying is you take 1.85 and you divide it by 3.5. And when you do that, you get 0.5. Excuse me. Yes, 0.5. So this 1.85 divided by 3.5 gives you that number. Now what you do is you work with 10 to the first divided by 10 to the second. Now when you do that, what you do, you subtract exponents. So you take the first number and you subtract the second number. So what we do is we say 10 to the 1 minus a negative 2, which is the same as 1 plus a positive 2, since two negatives make positive. So now you got 1 plus 2, which gives you 3. And that, in fact, is the number. What you want to then do is convert it to the scientific notation answer. And you'll notice we have to move it over 1 there, which means you have to knock the number up, so it becomes, my bad, you made a smaller number become a bigger number, so this has to come down 1. And that becomes your answer. So you're given 18.5 divided by 0.035. So what we do is we set it up as a ratio, divide into two parts, 1.85 times 10 to the first divided by 3.5 times 10 to the minus second. And you divide these two as separate entities, and there you go. So in continuing this, let's take a look at another mathematical operation using scientific notation. What if we took let's see, let's take the number 24.68 multiply by 1022. Okay? So the first thing we do is we're going to convert each of these numbers. And we're going to go with 2.47 times 10 to the first. Notice we convert that. Multiply 1.02 times 10 to the second. Again, notice we did the move there, and we did the move there. Ah, my bad. Glad I checked it. 10 to the third. Now, what we do here is, once again, we're going to break the problem down into two parts. We're going to take 2.47 and 1.02, and we're going to multiply them together. When you multiply that together, you get 2.52 times, and when it comes to the exponents, when you multiply in exponents, you simply add them. We add them because this is a multiplication problem. And the result is you get 10 to the fourth. So it's already set up in scientific notation. So brilliant. We're good to go with that. So I'm going to do one last problem in this section. And the problem says that we've got, let me get my act together here. We've got 28.23 divided by 187.2. To solve this problem, we first convert each number to scientific notation. So it's 2.82 times 10 to the first divided by 1.87 times 10 to the second, again because I'm moving my decimals. Now what we do is we're going to divide the problem into two parts. We're going to work with the exponents separately from these two. And if you take 2.82 divided by 1.87, it gives you 1.51. If you take 1 subtracted 2, you get 10 to the minus 1. Wow, that was a bit odd, but 10 to the minus 1. And that's what you did. So what we've done here, we've converted numbers into scientific notation, and then we carried out basic mathematical manipulations, which is the multiplication and division of numbers that are in scientific notation.